So the records go directly to your local drive, right?
Yep, recording started.
Not on the slide. Okay. So welcome everybody. So we'll be starting again. We believe we're going to finish the basics today. So subsequently, we might not be doing all the lessons. So we might just take lesson 3, wherever we stop, you finish it up and we start again in lesson 4 so that we'll be able to finish up. Reason being that we do this for just 1 hour in a week. So we won't have time to, if we want to finish every lesson on a spot, it's going to be difficult for us to finish this. So presented to you, courtesy of OffChain. So this is a disclaimer, and I would have changed it to 3, my name, and let's kick off. So, can you see? I have to turn this off. Oh, okay. Sorry, technical problem. Let me fix it. Okay. Just a moment, sorry. Okay. We're back. Okay, sorry, I have to share my screen again. Okay, can you see me now? Am I back?
Yeah, now it's sharing.
Okay, so I can't remember where we left the other time. I guess it's here. Oh, 5 minutes is gone already. So the last time we tried to, I don't know, did we do here? And do you still remember where we stopped last week? Okay, so here we try to I think we did here last week. I mean the last time. Okay, so I think we've done here. So this chapter 6 just basically imports a contract. So when you want to make your contract, cleaner, you can divide it into different parts and you can just import. And after you import a contract, okay, you inherit that contract. So chapter 7, we talked about how to make some pointers and when to use storage memory, okay, for some type of for some type references like string and etc. Yeah, I think we did this. So let me move to the next one. Okay, so here we start. So now remember we're just building a zombie stuff. So the zombie is like a game in the block on the blockchain. So this zombie, when we click feed, our zombie is basically going to eat another zombie. So it's a game where you click on a zombie, the zombie eats another zombie, and if you win or something like that, or whenever a zombie feeds on another zombie, okay, there is a kind of mutation. Okay, so a new zombie is formed, and here we're going to see how we're going to do the logic of trying to change the DNA of the zombie. And So basically they say I don't know if we've done this anyway.
I think we got to this part yet. Yeah.
We've done this, right?
No, I don't think we did that.
Okay. So now we're going to write a logic of feeding a zombie. So they said the formula for calculating, okay. So how do you calculate the new zombie's DNA? So when a zombie feeds a zombie, how do you calculate? You basically just find the average, okay, of the feeding zombie. That's the message the sender, okay, zombie, and then the target zombie DNA. And that is how you get it. So this is the zombie of the message sender. This is the target, okay? And then you find the average, and that is it. Just basic logic. And so what do they want us to do here? They want us to first make sure that it's not, okay, we have to make sure that the target zombie is not longer than 16 digits. Remember our DNA, the zombie DNA was coded to be 16 digits. If you remember this very lesson, and then so now what do we want to do? We can set the target DNA zombie to be equal to this. Power 16, we return a number raised to power of 16. We've talked about this before, and there is a description for that Ben sent out. So let's just go to the coding straight. So we want to make sure that this, whatever target zombie, target DNA that is imputed here, because probably I don't know how it's going to work. I've forgotten. Since whatever target zombie we put, because this is a blockchain, when you cannot come back to change anything. So you have to make your parameters right. So we basically want to say that anytime a target zombie comes in, okay, basically trying to say, take this target zombie parameter and make sure it is equal to 16. Don't really know what I want to say. And then next, our function should declare a unit named new DNA. I'm a bit confused here. And set it to equal to the average of zombies DNA. Okay. So I think there should be a required function here, but let's just go down and see what they want us to do. So we create a new DNA. Basically, I shouldn't be coding again. I should just want to create a new. So now, okay, this logic says when a user, you say this is a public function. When a user calls this, make sure that this is called by the sender, message sender, okay? The color of this control actually has the red key. And then we please, somebody is speaking on the
microphone. Hans, please go mute. Hans, please go mute.
Ben, it seems you have to mute.
I can't. Hans, go on mute. Somebody else is talking.
I'm so sorry. Okay.
There. I've muted them. Go.
Okay. Okay, so when we get a new DNA, okay, what do you want to do? We want to find a new DNA, which is similar to this logic. Probably I don't need to type it, but let's just, probably this is the last one we're going to type. So we do my DNA. So we do this. And then we say plus what? The target DNA. And then we basically divide by 2 to give us the semicolon. Okay, so this gets this. And but now let me see what my zombie gives me. My zombie is a pointer to zombie. Let me see. My zombie is a pointer to zombie. Okay, so I want to get this DNA. Okay, so what do I do? Zombie.dna. Okay, so let me go back. My zombie.dna. Let me get this out here so that we see what it's all about. Let me put it here. So we are basically making here, we made a pointer to this zombie strut, and what it does is that it takes zombies. Wrong, right? I'm wrong. Okay. Here. I'm sorry. We left this a long time and I didn't revise it. So this is like a pointer. And this points to, okay, this points to this, okay? And so when we call it, we do dot. Okay, that's right. Okay, so my zombie.dna and my zombie.name gets this. So if we want to get the name of the zombie, okay, we say my zombie.name. If we want to get the DNA, we say my zombie.dna. And then what else? Okay, so they say once we have the new DNA, let's call this create zombie function. Okay, nice. Once we have it, let's call this function. And then what was this function all about? Does it take a parameter? Okay, yeah. This function takes in, let me just put it here so that we see what we're doing fast as I can. So this function is going to take some parameters. Takes in name DNA. So let's say once this zombie, okay, let's call this, we can look at the zombie factory tab. Okay, if you forgot which parameter this zombie needs, note it requires a name. Okay, it requires a name. So let's set our zombie's name to no name. For now, we can, okay, so this create zombie takes into parameters, name and DNA. Right now, they want us to just say no name. And the next parameter is this DNA. So this DNA should be the new DNA, if I'm not mistaken. New DNA. Okay, that's all. But here, I think there's a problem here. Let me take a look. It's a first we need to make sure that the target DNA is no longer than 16. To do this, we can set DNA equal to only take the first, to only take the last. Okay. So do this. So I guess this is very easy to understand. So let's go through it. In this function, okay, when we call it with 2 parameters, zombie ID, target DNA. So basically, when you want to feed with another zombie, okay, or when you want to feed another zombie, you click on this. This function is called. First of all, it tries to check, is the color of this zombie, I mean, whoever that owns this zombie, let's go back because it's been a long time. Zombie.owner. Let's go to zombie.owner and see what it's all about. Zombie.owner. Okay, zombie.owner is a map. Okay, this map maps, each the zombie ID to the address. Okay, so this is like kind of a security measure to make sure that the address, whoever is calling this contract, okay, has this private key. So if that is so, the code continues. If it is not true, somebody can call this contract with whatever parameter because it's public, So this is a good check, to make sure that nobody calls in with, with your ID, because, because it's set to public, anybody can actually call this function. Like if you know code well. So we're doing it. You can actually call this with Web3. Okay. So this is a security measure that ensures that whoever that called this ID, is it actually the owner? So this will be, because we've already mapped every ID to an address. Okay, let's go back. So the wire statement, very nice. And this picks out whatever DNA the person has, okay, and makes a new zombie. So when you call this function, a new zombie is created using the DNA of the target DNA. Using the target DNA and the zombie's DNA. And then it calls this function, okay, to create a new zombie. So this new zombie, we have a name, no name, and then we have a DNA, new DNA. Let's go back again to see what this function is. You see, this function is private. There's a problem. This function is not going to work. Okay. Now, sorry, this is where we are. Let's go back. You can see this is a contract called zombie feeding. Okay. And this zombie feeding contract inherits zombie factory. Okay. Let's go to zombie factory and see what happens. In zombie factory, because we inherited zombie factory, everything in zombie factory, every function in zombie factory is like invisibly here. Okay. Now let's go back to zombie factory and see. But you know what? This is a private function, meaning any function that inherits this contract cannot call it. It means it's not visible to this contract. Okay. If it is public, anybody can call it. If it is external, any other contract can call it. If it is what's the other one? Internal. Internal, like internal means any other function here can call it. So this might not work, but let's go and see what they want us to do. So I hope you understand what this function does. And let's move on. So yeah, very nice. So they are here. They want to really explain what happens. Okay. So you remember our function has visibility. This function has a visibility private. This is a function called generate random DNA. Okay. The visibility is private. Okay. What does it mean? Here they're trying to say that public private function and internal functions are more or less the same. Okay. One of the differences is that, okay, first of all, let's say there are similarities, is that when you call a function internal, it means only the functions inside this contract can call it. Okay. But when it's but when it's private, okay, it's special in the sense that if another contract inherits this contract, that contract inheriting it cannot call it. Okay, you saw what happened in the other place. So there is another kind of function visibility called external and public. We've used external and public a lot of times, like in this create zombie, random zombie. Okay, I want to believe that when you want to enter this game, the first thing you do is to call this function. So anybody can call this function because it's what? Public visibility. But there is another kind of visibility that looks much the same like public. It's called external. The difference now is that in external visibility, only a contract, like public this is of public visibility. Any user can call this. Okay, but in external visibility, only a contract can call it. Now, they are saying here that they are going to tell us later where to use external and public, or I mean, when best to use external visibility. So we don't need to worry about it. Let's follow the course. And here, okay, this is just basic example. No need to explain all of this again. So you can see we found out a problem that our this feed zombie contract, okay, inheriting zombie factory, okay, called a contract, sorry, a function, a private function. Since it is private, it cannot work, okay, because it is not visible to the zombie feeding contract. So if we really want this code to work, okay, we need to change the visibility of create zombie function in the zombie factory contract. Hope that is a little bit clear. So we need to change this to, we can change it to internal. Internal will be better because, yes, internal, we don't want anybody to call it. We just want the contract to call it. So it's better we change it to internal. And here, very good. They said, can you see, they say change this zombie, create zombie function from private visibility to internal. You already know why we have to change it. Now let me change it. Okay, no need. You can just type internal. Nice. Oh, it should turn blue. Why is color changing? I make a mistake on the spelling. Okay, anyway, let's move on. This is just what they want us to do. And so now, just let me go back quickly. Okay, changing this to internal, what it has done is that it has helped. I mean, when we run this code, okay, when we run this function, or when we call this function, this can run, okay? This can run because this function is available. This function is available to this contract. With this, we've learned how, hi. Hello, can you hear me? It says my internet connection is poor.
Sounds fine to me.
Okay, so this is cool. With this, we know a lot about visibilities, function visibility. So the only thing we are yet to know about function visibility is to know when to use external or public, So we'll get to know that later. So remember, this contract actually, fits on, it's like a game. There are a lot of games that actually mimicked this zombie, what's it called, crypto zombie. A lot of games out there, a lot of NFTs, exactly everything. You just get a player, blah, blah, blah. We see how it works. Let me, so now they want to add another functionality to this. Okay, they want you, instead of just eating the zombie in zombie, they want to eat another kind of NFT, so they want to connect to CryptoKitties smart contract. So what they want to do is that they want to interact with CryptoKitties contract and just get some zombies and try to eat or try to mutate the gene, or try to eat CryptoKitties, to be able to form another kind of DNA. You remember in the feed and multiply, whenever you call the function, what it's going to do is it's going to get the target DNA and feed on it and then mutate the gene and form another DNA. So they want to make special whatever that is not just crypto zombie. They want to make crypto zombie kitties. But the importance of this lesson is that is to know how to interact with other smart contracts. Okay, so when you start creating your smart contract, you may need to interact with some other contracts. Is an example is, let's say you want to make a DeFi contract, okay? And in your DeFi contract, let's say your farm is let's say Ben's farm, okay? So in Ben's farm, you can actually buy USDT, okay? And use USDT to buy Ben. Let's say the name of the token is Ben, okay? So, but now, how do you buy USDT? You need to interact with Pancake Swap, contract, right? If it is on it, you need to interact with Uniswap contract, to be able to swap. So anytime you want to interact with any kind of contract, any smart contract, you need the smart contracts ABI and the smart contracts address. An ABI, I've forgotten what it means, something binary interface. But an ABI is just what does, it's like it presents the functions that are callable, from a contract. Let's go, there. Task can, let's see what let's see what an ABI looks like. And really, anyway, no need to waste time. So now for us to interact with CryptoKitty contract, okay, we need to define an interface for it. Okay, so you can interact with any other contract, no matter what contract it is, and you can access the functions. So far the functions are, maybe they are on view, so you can access what it is, and you can call the functions if they are either external, public, external or public. So now let's take this example. So in this is a contract called Lucky King, okay? Sorry. Okay, this is a contract called Lucky Number, okay? And now we have, if we want to interact with this contract called Lucky Number, okay, we have to, can you see this contract called Lucky Number? What does Lucky Number have? It has a set number. You just set a number, okay? And then you can view that number, anytime. Can you see it? You can view the number here. So now, if we want to interact with this smart contract, we need to build an interface, okay? And then you can see how an interface looks like. It looks like a contract, but it just ends there. You say contract number interface. Number interface is referring to this, okay? You can call it any name. You can just say Lucky Number interface, okay? And you actually put in the function you want to call. Let's say you want to call all the functions here, okay? You can copy this and put it here. But now, in a special way, you only just copy, this, and you don't put in the, you don't run the main code, So this is, merely your smart contract sees this. It sees a contract, but it doesn't have any stuff in it, okay, like this. It's going to know that it's an interface. I think that this is not, actually, I don't know, can you hear me? If my internet is not working, I wonder.
I'm hearing you fine.
Hello.
But I'm guessing maybe your VPN's down.
Huh?
You sound fine, but I'm guessing your VPN.
We can hear you fine.
Okay, yeah, I require VPN for this. Yeah. In fact, I didn't connect my VPN anyway.
That'll do it.
I didn't connect it because having a little issue with the VPN anyway. Okay. So let me be fast. But I need to, this actually is not the current way to call interface. If you want to call an interface, you just say interface and the same thing, but you change this contract to interface. Okay. So basically, if we want to call this if we want to call this lucky number, okay, what we basically do is maybe come over here. Maybe before you create it, here, just on top of it. How do edit this? Okay, on top of the contract. I mean, you do it just before the contract, okay? But because it can't allow me, come over here. Oh, okay. Solidity with the doc. Okay. So it's very easy. Just change this contract to interface. So this also, I mean, it's going to run on this code, okay? This also brings us back to the pragma. You remember before you write a smart contract, you put in the pragma. Why are you putting these things? You're trying to tell the compiler, compile this code using, Solidity version 3, not greater than Solidity version greater or equal to 5, anything between 5, simple, okay? Now, okay, let's say when you write this kind of code with this kind of interface, okay, in a Solidity version 8, you see the code is going to break, okay? So that's why it's good to specify you specify your pragma well. That's the version of the compiler to use, okay? So when we run this code with this kind of interface name, it's going to run, okay? So, but we want to use this opportunity to introduce you to the doc. Okay, so everything we are doing here is already here in the doc. It's even very easy to understand. And so let's type interface. It's not, I mean, so you can, anything you're looking for, if there's something you don't understand or you want to clarify, you can just come over here and click, come to the doc and type it, whatsoever. In fact, they even have tutorials that can also help you. I hope I'm gonna find what I want. I don't want to waste time. Use. Time is running. Okay. So I guess, okay, nice. So here they are trying to talk about the old contracts where you do this, okay? And blah, blah, blah. Okay, no. Anyway, however it is, I don't want to waste time. Just know that now you can use interface and just call whatever you want to call. After this is just to introduce you to the doc. You can find whatever you want here. You can, go to introduction, and there is a little tutorial that really helps. And that's just that. Okay. So if we want to interact with this smart contract, we have to put in the ABI. That's in Solidity, a special way to do this is to just form an interface. Okay, that interface is like the ABI. We're going to see ABI later. But here, what do they want us to do? They want us to call the CryptoKitty function. And this is the function they want us to call. Okay, so we have to know the CryptoKitty's smart contract, okay? And then we need to know the function to call. And then we put this function into an interface, okay? The Solidity is going to convert it to ABI for us, okay? And okay, let's just do it. Let's do it now. Okay, so create Kitty interface here. Let's do it now. But let me just do it here. They said create an interface called Kitty interface. Okay, you can actually call it any name. Okay, and remember, this looks just like creating a new contract. So we use the contract keyword. Anyway, Yeah, so we can actually default to this, okay? But I just want to show you what is applicable in newer codes. And then they say the word. Inside the interface, define the function get kitty, and but with a semicolon after the return statement. So let's look at this and see how it works. So we do the function, blah, blah, blah. So this is the function we want. All right. Coming at the end. So, I mean, if you can use this, might be confusing to you, just use this. So what's about, let's say you want to interact with a contract and there are 5 functions you want to interact. So what you do, just get those functions, copy and paste it, okay? And remove whatever it is and just put a semicolon. Okay, for this compiler version, you use contract, but for newer ones, you see interface. So when you see interface or contract, you don't get confused. So let's keep going. So remember, we need, I mean, if we really want to interact with this contract, we've actually made an interface, okay? Can you see the interface? And then we need another thing, and what is that we need? We need the contract address. And here they created a contract address. Let's quickly run over here. They said, okay, this contract, blah, blah, this is an interface, okay, that we've created the other time. So we need to get the contract address, okay? And then we need to point to this contract. Basically, this is how it is done. So so now you create, if you want to create a pointer, you know how to do it. You can just call it any name. You can just say number contract, okay? You want to point to this, you want to point to the contract we saw previously, the number contract, that's, okay? So what do? We need the API, we need the contract address. This is the contract address, and we've already formed the API, I mean the interface, okay? We've already formed an interface, and this is how you form an interface. And this is the function we want to call. To do. Okay, let's move on. So you now create a pointer to that to that contract. So how do we do it? First of all, let's say you can write a name number contract, okay, of type what? You made the type the interface. Okay.
Just one, just forget about that.
And then this is what you do next. You say interface, and then you put in the contract address. Very easy. It's very easy. And here we're going to do same with crypto contract. We want to initialize this Kitty contract. So what do? We create. What do they want us to do? We've saved. Okay, so here they've actually had coded the crypto contract address, and okay, and they want us to create a Kitty interface named Kitty contract and initialize it with clean. So they just want us. So what do we do? Let me be fast. Let's get this. We want to create an object, Kitty contract. Okay. And what this contract does is that, remember this? And put in this address. By your semicolon. So basically, whenever you call this Kitty contract, this is pointing to Kitty contract address. So this is just how it's written. So let's say we want to interact with sushi swap. Okay, what we do, we get the functions we want to call in sushi swap. Just get those functions. You can just make something like this. Let's say you want to interact with sushi swap. You can say contract. Okay, let me use interface so that to be more modern. Interface. Okay, let me call it sushi swap interface. You can call it any name. Just make it easy. Okay. Let's say in sushi swap there's a function called swap now, and I copy the swap now, swap now interface. Function, and let's say the swap now takes in maybe two variable, token 1 and token 2 and token 2. Okay, just giving you an example. And okay, external. Okay, let me just chip in something very fast. Here they created an interface, and they use the old method, okay, where they say contract, give it whatever name you want, and you paste in the function, okay, excluding whatever. But here, if you're using interface, okay, method, this is what you're going to do. You're going to change everything from whatever visibility it is going to be, you're going to change it to external, okay, and you're going to make it view. So external view, I think that's the basic difference. Returns. So whether the contract has public, change it to external, okay, that is just the take-home assignment. And whatever, if it's going to return whatever, you put it there. Okay, let's say it's going to return a unit. Okay, now you let's say here you have something like here you now put in the sushi swap. You can hard code it or not. You can say sushi whatever swap contract address, okay, address, and then let's just call it whatever. Okay, let's assume this is 16 and it's correct. Okay, so now when you want to initialize this sushi contract, which we're going to do here, sorry, this is going to be done inside the contract. Nice. So you put in the interface outside the contract, okay, but everything is inside, and you just say you want to create a pointer, okay, sushi swap address, sushi. You want to create a pointer called sushi, let's say sushi swap contract, okay, and then of type what? Of type interface. This interface we created, whatever name it is, and then you put it like this, and you pick this again, and you put in the contract address. So anywhere you put in, let's say, okay, we're going to see how you're going to use it. So anytime we call sushi swap, this is already a sushi swap contract. Okay, whenever this is like a pointer pointing to this contract. It already has the API, okay, in the form of an interface, okay, and it has a contract address. So beautiful. So this is where to go. I'll just push next. So but for this lesson, this is what we did. We got an interface of from CryptoKitty called the Get Kitty. Okay, we want to get some of their kitty and exchange the DNA, and then blah blah blah. We already said that. So you notice something in the Kitty interface. Should I go back? Okay, I can use this. You notice something that sometimes, I mean, all this while we've only been returning only one, only one kind of, maybe one number, one number, but sometimes some functions return a lot of numbers, okay? So how do you, let's say you want, let's go back, wait, 1, 2. Okay, this is the getKitty function, okay? When you call this function, it's gonna return lots. Can you see what it's gonna return? It's gonna return like 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we need is maybe basically the gene, you just need the crypto gene, the Kitty gene, right? So how do you just get only this? And that is what we're gonna say here. And it's very simple. So let's say this function, okay, returns 3 stuff, and you wanna actually get it. How do you get it? There are so many ways to do it, but the way these guys did it, there's now a better way, a simpler way to do it. Is that, let's say you call this function, okay, you assign A, A is like 0 now, B, C, and then you call this function. So when this function is going to, whatever thing is going to return is going to push into this. Okay, let's say it has, okay, now it has A, 1, 2, 3, okay? So A is automatically going to be 1, B is automatically going to be 2, and C is automatically going to be 3. Let's say it returns strings, okay? And the first string is maybe tablecloth wire. So A is going to be, but you need to change this to string, okay? So A is going to be table whatever Y, okay? But now, sometimes you don't need all of the returned argument. You just need only one. Okay, what do? You use comma to whatever one you don't need. Just use a comma. Don't put in any variable to it. Just use a comma and take it out. So that is what we're going to do here, since we want only Jane. Okay, when we get the Kitty Jane, we just comma out the ones we don't want. So what do they want us to do here? I may not, if it is already what we know, I may just skip it. Make a function called feed on Kitty. You can do this. I'm putting these 2 variables. We can do it, right? And then the function could then call the Kitty dot. Okay, let me code this. Let me code this because it has something we've done. Make a function called feed. So let's make a function called feed on zombie. And then what does this function take? Takes in two stuff, and takes in 2 units. And unit 1, unit 2. And the first unit is this. Okay. The second is that's going to take a crypto zombie ID, okay? And it's going to match it with a Kitty ID. You understand? So this is kind of, we want to feed on Kitty. We are interacting with another contract, and we've imported we've interfaced it, okay? And we've created a pointer to point to that contract. And then they said the function should first declare a unit named Kitty. Okay, very good. This is like the contract should be any. Okay. T is a unit. And then note, in our Kitty interface, Gene is a unit 256. Okay. So what? Okay. 256 and unit is still the same. You know, you can call this 256, or you just put it out. It means the same thing. So the function should then call the kitty.getIt function. So this is the main reason why I'm even writing this code. I will tell you what it is. Function with. It's going to call this, okay, with this. I will explain it in a moment. It's going to call this with this, comma, okay, and store genes in kitty DNA. I don't even know what I'm doing, man. I'll get it right anyway. And last one. Remember, getKitty returns a ton of variables, tend to be exact. But all we care about is the last gene. Count your commas carefully. Finally, the function should call feed zombie. Don't worry, we're gonna make it cleaner. Feed zombie. Feed zombie takes in 2 parameters, right? Takes in zombie ID of the user and the target. So, anyway, clean. Okay. So the main reason why I even wrote this code is just to show you this. So can you see? Oh, okay, wait. Let's discuss this. There are so many things I need to type here, but those ones will be easy. So can you see this is kitty contract? What is kitty contract? Remember, we initialized our. So this is actually pointing to the kitty contract, okay? And we did a .get kitty. What is .getting? .getKitty is going to call a function called getKitty in the kitty smart contract, okay? Remember, this is the address of the kitty smart contract. We've already initialized this and we've put a pointer to it, okay? So when we do kitty contract .getKitty, so this getKitty is going to know what to call, okay? It's going to get some information about the contract, okay, using our interface, you know. Sorry, using our interface. Can you see? So as we want to call another contract, another function in the kitty smart contract called, let's say, kill kitty. We need to put the function here, okay? Okay, and then when we want to call that contract, we just say kitty contract. It can be any name. We are calling it kitty because we put a pointer to it to point, and we called it kitty contract, okay? .get or new kitty or whatever function we want, okay? Whatever function we are calling in the kitty contract, we should make sure we put it as an interface here. Okay, that's pretty easy. And there is something we're missing here. We care about genes. Okay, so when we call this, it's going to return a bunch of numbers. Okay, you remember this is basically going to call this function in the kitty smart contract. Okay, and remember this is like it's going to return all these numbers, but we only need the last one, and they're already giving us an expo. It's going to return like more than 10 stuff. So let's make it. So they are 10 in number. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the last one is going to be. So it's going to meet every other 10 here and just give us this. And then whatever value that is here is going to put it in kitty DNA. And then it's going to use this kitty DNA, okay? And it's going to use it to call the feed and multiply function, which we've created. You know what the feed and multiply function does? You already know. It's going to create a new zombie by mutating the 2 DNAs, of the target and the caller's DNA. So So here we learned a lot of things today, how to interact with another smart contract using the interface and the contract address. But this is like a flaw. You had coding this contract here may not be the wise thing to do. Probably they will show us how to do it better in the next lessons. For this one, I think it's very easy. You can read about this. I've checked it. It's very easy. It's just a little logic, and it applies a little of the modulus operator. So you can go back and look at it. And then something else I might want to say here is that just like JavaScript, you can call a function and say if, all this while, usually when we call a function, we say require. We want to check if the caller is actually the owner of the crypto zombie. Okay, like this is a public function. Okay, I'm here now. This is a public function. Anybody can call this, right? But you see, we need to also put a require statement here, because anybody can call this contract and make sure that the owner is the owner of this zombie ID that is actually calling this contract. Okay. And how does a computer, how does this contract know the owner of this, match the zombie ID? Cool, we already did it before. We already, whenever you create a zombie, it's going to make a zombie to owner. And then it's going to give the person an ID, and it's going to save the address of the person. So it's going to say message.sender equals to blah, 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 blah. Okay. But here, the only thing you might need to get here is that even though you might do for numbers and some other stuff, you can do, is this equal to this? Okay. But for strings, it cannot be done easily like that. You need to hash it. Okay, you need to hash the string in order to compare. This is just the take-home assignment here. Okay, when you want to compare, is this equal to this? If it is number, I can just say is. I can hit right here. If message.sender, message.sender is equal to, let's say, whatever this address. So let's just use this. Then run this code. Okay, so when I call this function, okay, blah blah blah. Yeah, okay, good. Paste tab. Say if statement, so use that. Okay, tab it. And so when I call this function, it's going to check is this address equal to this, whatever logic it is. But if it is going to be a string, you need to hash it. Okay, you remember we did something like this where we need to hash a string in order to find, I've forgotten what we did then. So this is just the take-home assignment then. The knowledge to get there. So we have like 5 more minutes. And then, so this is basically the end of this chapter. So here they talked about how they implemented it. How, this is like how the code you're going to put on your front end. Okay. So when you look at this very well, you see that it's basically JavaScript. So this is a JavaScript implementation. They actually use a library called Web3.js. We're going to see it, okay? That's why you need to know a little JS for taking this course. So this is there's a big whole topic for that. And I don't mind, I want to go a little further just to lesson 3. Because in lesson 3, okay, I want to point out something before we close. Then I will give out the assignment for lesson 3. So remember when you call a smart contract, okay? When you compile a smart contract, we're going to see how to compile a smart contract the next time. I'm going to use Solidity so that when you are doing all these things, or you can watch a tutorial, okay, about how to use Remix. Remix. I urge everybody to watch this. Find a tutorial that teaches you how to how to use Remix to compile your code. What it's going to do is that you will be running this smart contract you coding already, okay? You get it and run it in Remix, and you see how it works. And in fact, you can interact with the smart contract. You'll be happy. You see yourself. You see that what you're creating is real, and it's not different from so many other contracts out there. Okay, so find a YouTube video. If time permits next time, I'm gonna do this. But here it's trying to say whatever you commit to the blockchain, okay, cannot be changed. Let's say we compile this code and we push it to the blockchain. We cannot change it again. It's going to remain like that, okay? And that is a flaw, where I told you that this is like a fault. This fault is that if, let's say, CryptoZombie decides to change their contract address because they found a bug somewhere, in their smart contract, they cannot change it, right? And they didn't put an update, something that can help them to kind of interact with that contract and change it. What is going to happen is that they're going to make another contract. And when they make another contract, they're going to have a new contract address. Okay, what happens immediately is that our contract might be useless. It may not be totally useless, but the feed on Kitty function is going to be useless because this feed on Kitty function is already initialized to point. We remember this. It's initialized to point at this address. So we can create it in such a way. We can create this in such a way that we put it in a function where only the owner of this contract can actually code the address that can be. So let's say Kitty changes the address tomorrow. We can just hit the function up, okay, and change whatever it is. So that takes us to so many things. How to modify a function to make sure. Like the other time, we saw how to restrict a function. Even though a function is public, we saw how to use require. Okay, here we saw how to use a require to restrict who calls this function. Okay, who runs this code? But there's another way to do it where you can even restrict who actually calls this function. It is called a function modifier. Okay, when you use a function modifier, even though it is going to be public, you can use a function modifier to actually specify who is going to call this contract, even though it is available to the public. And but here they want us to simply, I think you can do this. They want us to not make this hard-coded, okay? They want us to take it out and instead create a function that takes it in. And they say delete the line code, okay? And then change the line where you created Kitty to declare, okay, we just clean. And so we make another function, okay? I know why I'm doing this part. I want you to see how you can make this work. And then we create another function, and this function takes in an address. Okay, we need to write that it's an address. Address. Paste. And this function is going to be a standard. It can only be called outside by a smart contract. And then it's gonna take this. And then okay, let's see what this function is. Whenever you call this function is of visibility external. That means it can be called by another contract. Can only be called by another contract. Okay, cannot be called by our contract. Okay, then what it does is that it takes in an address, and when you call it, it's gonna put in this address to the Kitty interface. Okay, And basically it's going to do what we did it's going to do what we had the other time, okay? But now we can change whatever address we have here. It can point to whatever address we want it to point. Let's say Kitty smart contract changes the address. We can simply change it here, okay? But now there's a flaw in this. The default in this contract is that anybody can actually use their smart contract. Let's say I want to spoil this contract, okay? I can actually use my smart contract and change. I can actually use my contract, call this function. You know how to call it already. You create an interface, okay? Point to this, the contract address of this contract and call this function, okay? And then change this address. So we need to restrict who calls this function, even though it is an external function. And I'll be fast here because so here we talk about how to do what they call the function modifier. Okay, so in the function modifier, you can actually modify a function and restrict who calls it. Okay, but before then, okay, you need to know there is a library called a Solidity Library that is open to everybody, where you can learn a lot, called the Open Zeppelin. Open Zeppelin, it's like, I can't tell you all the story, you can read it up, but they have a lot of contracts where they've been verified to be cool, security wise, tight. So you can use their they already made code. Okay, you can also learn from there, So when you read this, it's going to tell you more about it. Okay, so but what are we concerned about? We are concerned about how to make a function modifier. You see this smart contract copied from OpenZeppelin has a contract called what? Ownable. So what it does is that it gives let's say you create a contract, okay? It actually gives it an owner. So that is why so many people can roll, you can give it an owner and you can give a smart contract an owner, okay? And then that same guy, if he or she has a malicious intent, can call into that contract and steal all the money, okay? So it can be for good or bad. So depending on the intent of the man, but you can also renounce ownership or whatever. But why are we here? We want to see what a function modifier can do, okay? This smart contract, let's look at it. I won't go deep, we've already known about this. Here, I'm going to introduce the constructor. Constructor is like a kind of a function, but it's called once when a contract is initialized, when a contract is deployed, okay? It's going to be called once. Usually we use it to, put in some specific parameters, okay? Let's remember when we called, like the function we created the other time, just the last time, where we decided not to hard code the crypto address, okay? We decided to call it ourselves, okay? So when you're creating a contract, this contract and everything, you can actually call it in constructor, okay? And you put in the now PT contract address, okay? You can put in the owner of this contract, and just say message.sender equals to owner. What does it mean? It means this is when this contract is going to be deployed. That is when this code is going to run. Remember, a constructor is a special function that runs only once, and it runs at when this contract is being deployed. Okay, so when this contract is being deployed, who is deploying the contract? Is the message.sender. Okay, so let's say if I deploy this contract, I'll be the message.sender, and it's going to equate to this owner. You see this owner state variable, okay? So I'm going to be the owner. So that is it. And now we can now use it to, we can now create a function modifier, okay? Where let's see how it works by looking at a function. Okay, this is what we call a function modifier. A function modifier function works, or how it is called. Okay, let's take an example here. This is renounce ownership. Let's say this guy He's a very nice guy. He said when he deploys this contract, he's going to renounce ownership. Okay, he's going to, so that he doesn't have influence on the contract, or probably he wants to change. Maybe he's now the CEO. Let's say it's a DAO, and when you are no longer the CEO, you transfer ownership to the new CEO. Okay, so there's a function for that. Let's use this as an example and see what a function modifier is. So now, when this contract is called, can you see if you call this function called renounce ownership? It takes no parameter. Okay, it's public, anybody can call it. But there is something added here. Only owner. What they say, we've not seen this stuff. This only owner is a function modifier. Can you see what it is? So let's go through the function modifier. A function modifier is like a special function, but you don't write function, you just write modifier. Okay, and you put in whatever thing you want to put in there. Okay, and then can you see here this owner only owner modifier? Okay, what it does is that it does require. It says require is owner. So it's going to say what is its owner is going to be called. If its owner is true, then this function is going to run. That's this function is going to run here. Remember, this function is going to run. Let's see what its owner is. Okay, so who is its owner? So it's going to this is going to go from here and whoosh, enter here. Okay, and then call this function and say owner equals to messenger sender. That's whoever is calling this contract. Is it equal to the owner? Remember, the owner has been set when we launch the contract using the constructor. In fact, it's not a must anyway, but every contract that is first deployed has this constructor. Okay, that's where you send some certain parameters. You know what to set, when you go on, like you've seen this, okay, and some other stuff. So now, whoever calls this function, even though it's public, okay, first of all, this function is going to say function modifier only owner. So it goes to only owner modifier and does require its owner, and then it takes it back to this function. Okay.
I think we should do a quick time check here. It is 8:15.
Oh, 14. Okay. Is the message on sender? So in 1 minute I'll be closing. Is the message on sender equals to owner? And if it is not, this contract will not run. If it is, that's the owner. This contract will run. Okay. So, and that equally points you straight, and you already know that this very stuff we made here, this very function we created here, we need to maybe use a function modifier so that no contract calls it. If the contract is not from the owner, it won't be called. So I took time to quickly rush here and extended to 10 more minutes. Okay, why is this so? I think this is the only hard part in lesson 3 that you may need somebody to explain to you. So basically, I will want you to go to lesson, here, everything I've explained. So take time to do lesson 3, okay? These other ones are very easy. Take time to do lesson 3 on your own, okay? When we come next time, I'm not going to repeat lesson 3. What I'm going to do is maybe in the first 10 minutes, I'm going to run through the code of lesson 3, okay? And we go to lesson 4. Okay, so the next time we're starting from lesson 4. Hope that is, and then what do you think about this? The other stuff are very easy. I've checked it. They are basically what we've learned, kind of more or less.
Yeah.
And with the 2 stuff I just introduced about function modifier, they can be able to scale through this chapter comfortably.
Good.
So when we come next time, what do you think? We move straight to lesson 4. Okay,
Yeah.
but I will try to, do like a summary of this.
Quick summary of that, and let's ask everybody here to do some homework. Come prepared for the next class. But if you guys have questions, raise them up in the WeChat and Discord. We're happy
Discord.
happy to help out there.
We're on Discord, so any question you encounter, writing this code, you can call us on Discord and WeChat. Okay, thank you everybody.
Cool. Thanks, guys.
Okay.